Hi everybody, welcome to my second video on writing a chemical formula or a chemical compound. Okay, today we'll be looking at writing a chemical formula of oxo and ions. These oxo and ions we are referring to of course radicals, when radicals are combined with metals. Okay, now let us just see an example here before we look into the actual examples. If you have a compound like this, you have the sodium sulfate, which is known as sodium tetraoxo sulfate. Okay, the word form will be given to you. The word form will be given to you as sodium tetraoxo sulfate 6. Okay, this one will be given to you for you to write its chemical formula. Of course, this is a chemical formula for it, but how are you going to write this chemical formula? Okay, now you first of all identify the element. Of course, in this case we have two parts. We have the metal part, we have the radical part. Okay, we divide this into two. The sodium, you have Na. Okay, the tetraoxo sulfate 6 is SO4, because you have 4 atoms of oxygen in this case and 1 atom of sulfur. Okay, so the valency for this radical is 2. Okay, and the valency for this sodium is 1. So here again you cross multiply, you have now Na2 and SO4. So if you are combining now, you will have Na2 SO4 as the chemical formula. Okay, now we have a list of compounds here that we'll be solving, meaning to write their chemical formula. Now we have the first in our list here. We have zinc trioxonitrate 5, we have copper 2 hydroxide, we have lead 2 trioxonitrate 5, we have sodium trioxocarbonate 5, we have iron 3 trioxocarbonate 4. Okay, now let us just start from our list. We have here zinc trioxo nitrate 5. We have that one. Okay, so in this case, as I said earlier, we have two parts. In this case we have the metal part, we have the radical part. Okay, so here you divide again this stuff. The zinc, which is the metal, the symbol for it is Zn. This trioxonitrate 5, that simply means you have 3 atoms of oxygen and 1 atom of nitrogen, which is NO3. Okay, so here the valency for this trioxonitrate is 1. Okay, and the valency for this zinc is 2. That is what you need to understand. Like if you are figuring out the valency of any element, that one is simple. In the area of the radical is somehow difficult anyway, you know, because you have to first of all determine the oxidation number of this nitrogen. in this case. That's why this one is being called trioxonitrate 5, and the charge on this is minus, just minus the charge of this. That's why this charge is a valency for this guy. If you are determining the oxidation number for nitrogen, you have to equate this charge, which is, like for example, you have here NO3 equal to -1 for you to determine the charge of this. So when oxygen is being combined with another element, the charge or the oxidation number for oxygen is -2. So you will have N plus 3 into -2 equal to -1. So when you multiply this, you have N minus 6 equal to -5. You transpose, you have N equal to -1 plus 6. So you have 5. That's why this one is being named as 5, trioxonitrate 5, because of this. The oxidation number for nitrogen is 5 in that case. Okay, so we go again to this one. Now the valency for this trioxonitrate is 1. The valency for the zinc is 2. So you cross multiply, this one affects this and these two affect this. But mind you, in this case, this one that we are multiplying, this valency affects both nitrogen and oxygen in this case. And of course, this one only affects the zinc. So you will have Zn and NO3 into brackets 2. So the compound now is Zn NO3 2. This is the chemical formula that you are asked to write, meaning if you are given a word form of this zinc trioxonitrate 5, this is the chemical formula. Okay, now we go to the next one again, which is okay, so we go to the next one, which is copper 2 hydroxide. Okay, we have copper 2 hydroxide. Okay, in this case now, earlier on in our previous video, I told you that if you see a number in bracket just after the metal, that number represents the valency of that element. Of course, you have here a radical, which is hydroxide. So you have, of course, the copper, which is the Cu, the symbol, and the hydroxide is OH. Okay, so the valency for this copper, of course, is 2. It's already indicated. You have 2 and OH is 1. So you cross multiply here in this case. And mind you, these two also affect oxygen and hydrogen. So you have now Cu and OH in brackets. So when you combine now is Cu OH brackets 2. Of course, that is the chemical formula for copper 2 hydroxide. If you are given compounds in a form of word, and you have to try to figure out its chemical formula. Okay, so out of the list we have 5 here in the list, so I'll just solve 2, so it's remaining 3. So I will just solve the last one. So the remaining, I will post that in the video so that you will try your best in writing the chemical formula of, in the comment section you will try your best to write the chemical formula of the remaining compound. Okay, so we have here we have ion 3 trioxocarbonate 4. Okay, you have again ion 3 trioxocarbonate 4. Okay, in this case, of course, this number also represents the valency of the ion. In this case, represent the valency of the ion. Okay, so of course the symbol for this one is Fe. And the trioxocarbonate, you have carbon, you have oxygen. But this trioxo, that simply means you have 3 atoms of oxygen and 1 atom of carbon. So you have CO3. And in this case now, since the valency for ion here is 3 and the valency for trioxocarbonate 4, it is 2. Okay, so we have here 3, we have here 2. So we cross multiply, you have Fe 2 and CO3 into brackets 3. So when you combine now, you have Fe2 CO3 into brackets 3. Thank you very much for your time. This is how you are to write the chemical formula for oxo and ions. Bye bye.